It's related to MongoDB and how you can build location-aware applications. It's about application development actually.
Application development.
So, so we'll be using Flask as a web framework, MongoDB as a backend, and deploy it to OpenShift, which is a platform as a service.
Okay.
So it will be all geared toward demoing how things work.
Okay, so it's demo. So you will actually work on it.
Actually, how things work actually.
Okay, okay. Because previous lectures and presentation practice.
No, this is going to be hands-on kind of. I will be doing things and showing you how things work.
Okay, and because I'm beginner, so I'm really beginner.
So this will be starting from beginning. So it will be starting the covering the basics of Python, Flask,
Okay, so Python and MongoDB,
which is a NoSQL data store.
and what's the point? What to do with it?
So what we are doing is we are developing a location-aware application. So we will be location-aware. So if you are standing here, which is nearest hotels near to this location? So we are developing a location-aware application. So if I'm standing here, so which all jobs or which all hotels are near to this location? So I can find that, and what's the distance to them?
Okay.
So this kind of an application. Flask and MongoDB. So Red Hat. Red Hat. I work for Red Hat. I placed out of India. So I'm just flying here for a conference. So my role is evangelism, so I travel around and speak at a lot of conferences.
Maybe we can speak.
Yeah, sure. We can speak after that as well. Sure.
Maybe after that.
Outside or in this room itself. Sure.
In my car.
Sure. Should we start or wait for some time? 4 minutes. Huh? So there are some OpenShift stickers if you want any. This is the product that I work for. It's a platform as a service. So if anybody wants, here are the stickers, you can take it. And if you ask some good questions, there are OpenShift USB sticks as well. So you can take these as well. So this is basically a bottle opener, so you can open beer or anything, and I use this stick. So. A cool stick if you want. You need to ask question first. You can take it now. Yeah. You're the first one. Yeah, sure. If you want, you can take it. Just remove. Yeah.
Thank you.
Yeah, welcome. Okay.
The presentation is shekhargulati, and the presentation title is bringing Spatial Love to your Python application.
Yeah, hello all. Hello. Yeah. So this session is about how you can build location-aware applications. So anybody who has built location-aware application before? Location-aware application. So fine. So we will be building a location-aware application in this session and deploying it to a platform as a service which is called Openshift. So I'm evangelist of that. So we will be using that platform to deployment. And let me start with confessing that I have been a Java guy for the last 8 years. And recently I started learning new languages, like I've been spending a lot of time on JavaScript, Node.js stuff, and Python. And I have been thinking, what the fuck? Python is too easy than compared to Java. So for my future project, I'm trying to work with Python as my primary language. So we will see how things work with web development in Python. So what's the agenda? So the agenda is we will start with Flask. So how many people have worked with Flask before? Fine. So we will start with taking a brief look at what Flask is all about. Then we will cover some MongoDB basics. So how many people have worked with MongoDB? Fine. So we'll start with basics there. We will look at how geospatial indexing works, because we require to build a location-aware application. Then we will build a location-aware application using Openshift and all these tools. And finally, we will deploy that to a platform called Openshift. Fine. So this is our brief agenda. So the application that we are going to develop is basically a location-aware job search application. So I have already written this application, and it is running on Openshift. So if I just go in here, and internet is working, then we should see application running. Yeah. So it's basically a faster way to find right jobs. That's what I call it. And what all you can do is you basically can register for a profile. So you can just go in and register for your account. So this is all HTML5, so you can register. You can pass in your email ID, password, LinkedIn profile URL, and all those things. Once you are done with this, you basically sign in. Because I already created an account, so I will just sign in. So I will just use my email ID and password as password. And I will just sign in. Once I will be signed in, I will be referred to a search page where I can search for jobs. Before we start, there are no stupid questions, only stupid answers. So if you have any question, just raise it. I don't like to wait for the end for the questions. If you have any question, just ask me at any point of time. So the tools that we are using are Flask as a web development framework for Python, MongoDB as our data store, and Openshift as our deployment platform. So these are the tools that we'll be talking about. So what is Flask? So Flask was created by Armin Ronacher, and it's basically a modern web development framework for Python. So it's basically start with a very minimalistic kind of attitude that you should basically start with a single file, and once you need it, you just modularize your code. Very easy to learn, very easy to get started with. So it's a micro framework for web application development in Python. So by micro framework, it does not mean that you have to plug everything, all of your source code in a single file. It just means that it's a very simple framework, and it has a very small core, and you can extend it by adding extensions. So it does not come up with the ORM, it does not come up with data validation, it does not come with all those things. You have to plug that in using extensions. It was inspired by Sinatra, which is a Ruby framework to build web application without much fuss. And it's built on top of Workswig, which is basically a WSGI utility library, Jinja 2, which is a templating engine, and it has sensible default. So if you have a static folder, it will basically be used for your static files like CSS, JavaScript. If you have a template folder, that will be used for rendering the templates. So good sensible defaults. But you can change those things as well. So why one should start with Flask? Because it's very easy to get started with. It's very easy to learn. You can start with a minimalistic thing, and then you can start learning more advanced feature of the Flask. But the code is just 800 lines of code. It's very easy. You can just read it out as well if you want to, and you can extend it using extensions. It has excellent documentation spread over 280 pages, so you can learn a lot from our documentation. You don't need a book. You just go in, it's a PDF or a HTML, you can just grab it. It's a very active community, so you face any trouble, you can get help on the Reddit, or basically you can get on the Stack Overflow. Very minimal footprint, just 800 lines of code. You don't have all those ORM bundled with it, so you don't pay the price of that. So what you needed, you just plug that in. So it does not make any choice for you. So whatever you needed, plug it. No choice, just a basic framework, just providing you routing and WSGI library. It has unit testing support. I have not played much with it, but if you want to unit test your code, you can just play around with it as well. So how you can get started with Flask? So you just create a new directory. I just created a Flask demo as my directory. I just CD into that. How many people use virtual environment here? I guess everybody. So virtual environment helps you basically work with different Python installations as well as different version of libraries. So you create a virtual environment, activate it, and just install Flask. Once you have installed Flask, that's what you need. You basically import the Flask class from the Flask library. You create an instance of the application. That's your application instance, is the WSGI application. You define your route. So route is basically when someone comes to the root URL, what you should do. So here we are saying that if someone comes to the root URL, it should basically render hello world. Then you basically start the application using app.run. So these just 7 lines of code is basically an application which can render hello world. Very easy. So if you need more routes, you just start adding routes to it. That's it to Flask to get started with it. So very easy to get started. Any questions? I talked about sensible default. So what does it mean? So this is my Flask demo folder. So in the previous example, I was just rendering a string, hello world. But if I need to render a template, what I will do? So in my hello function, I will just call a function called render template, which is again a part of Flask, and give it my template. This is my index.html is my template. I will give it a title and a body. Fine. And I have a templates folder here, which is basically having all my template, like index.html is my template. Similarly, I have my Bootstrap, CSS, and JavaScript in the static folder. So these are the default. So you create a static folder, plug all your CSS and JavaScript in it, create a templates folder, plug your HTML or any other templating language into it. It works by default. So these are basically the sensible defaults that Flask provides. You can change these as well if you want to. Another good use case where Flask fits in most to me is if you're writing RESTful web services. It fits a very good case. So if you're like the application that I'm using, it exposes a lot of REST web services. You can use a server, you can use client-side rendering or client-side templating engines. You can use Angular or Backbone and have your backend, which is just exposing RESTful web service. So it's a very good fit for that. So here what I'm saying is that I'm defining a function called jobs, which has a route called job/skill. Skill is basically a dynamic variable. So if I want to find all the jobs which are Python related, it will basically hit this route and give me all the jobs which are Python related. I can have different representation of the jobs. I can have a JSON, I can have XML, I can have HTML, because these are just representations. Similarly, I have another route where it says that I want to find a job with this job ID. So again, this is a RESTful URL for a resource corresponding to this ID. I will just call my viewJob function and return the job. Fine. Again, you can have multiple representation to it. So it's very easy to get started. So if you want to build a simple application where you just need some backend web services, RESTful web services, Flask is a very good alternative to that. So very good framework that you can use. So these are some basic. Now we will move toward application development later. So any questions so far? So what is MongoDB? So MongoDB is a NoSQL data store. So by NoSQL means that it does not follow the SQL paradigm, where SQL paradigm is that you define a schema, you use SQL statements. That's what not MongoDB is all about. It's a very generic kind of NoSQL database. So if you're looking for a replacement of MySQL or PostgreSQL or Oracle, MongoDB is the closest that you will get. Fine. It's an open source project. Initially, the company was called 10gen. Now they have renamed it to MongoDB because that was the product that they are trying to do. So now the company behind is called MongoDB rather than 10gen. The data that you write in MongoDB is written as JSON document. Actually, it is BSON, which is binary JSON. Fine. And JSON works very well with object-oriented languages because there is no object impedance mismatch. So in RDBMS, you basically have tables and you have objects. Objects basically are nested. Tables are not nested. So you have to create multiple tables. And then you use join to get the data. But MongoDB, you don't do that because you're just storing a JSON document. So A user object can have addresses in it. Rather than having multiple collections or tables, you don't need that. That's the biggest advantage of something like MongoDB. You can take your object model and just persist it to the disk. It's schemaless, so you don't have to define any schema. So you don't say that my user table will have username, first name, last name. You don't have to define that. Whatever is in your application code, that becomes your schema. So when you move to NoSQL paradigm, everything comes into your code. So there is schema, but schema comes in your code. So developer drives it. Rather than a DBA writing SQL statement or defining your table structure, that is not the true. Now everything is in your application code. So you make a change to your object, the same will be reflected in the database. It's very fast and horizontally scalable. Fast means that it writes data to the disk very, very fast because it's asynchronous in nature. So it does not wait till the data is written to the disk. If you work with MySQL or PostgreSQL or Oracle, you basically wait till the data is written to the disk. With MongoDB, it's asynchronous. So what it does is that it just make a request that this is the data. When the data is in the RAM, it comes back. And there is asynchronous process which basically writes to the disk. Fine. That's why it's very, very fast. But you can configure it. So you can say that this, because if you basically shut down your MongoDB till the data is not written to the disk, you might lose the data. To overcome that, you might say that I want for this collection or for this write, I want my write to be safe, which means that it will not say it's done till the data is written to the disk. So you can configure all those things. It's designed to be horizontally scalable and it's very easy to work with. Just start a new MongoDB, Mongo shard process, and you can do it. Most of the NoSQL database does not have a query language, but it has a very rich query language, which you can create indexes. You can use and or queries. You can do that, but it just doesn't have that joins. It has a support for rich documents, so you can have a document inside a document. So that's why you avoid joins. It's very easy to get started. Just download a zip file, unpack it, and you are ready to go. No one-day installation process, just very easy to get started. It supports geospatial indexing, which is very critical for writing location-aware applications. So I will talk about that later. Any questions before we move forward? Yep. If you ask questions, you can take pen drive, so please ask questions. So what's the terminology of MongoDB? So this is basically relational database paradigm. This is MongoDB paradigm. So you have a database corresponds to a database. In MongoDB, you also say a database. In relational database, you have something called table. In MongoDB, you call it collection. You have a row in table. You have documents in collection. Index corresponds to index. So like you create an index in the relational paradigm, the same do with the MongoDB. Instead of join, you have embedding. So a document consisting of another document. That's embedding. That's what you have. So terminology is quite similar, but two differences are document and embedding are the two things. So what is geospatial indexing? So geospatial indexing is basically if you want to find out because the application that we are developing is a location-aware job search application. So if I'm standing at this place, how many jobs are near to my current location? Fine. So some will be in the mid of Tokyo, some will be some other place. So I need to find that. So it supports something called near queries, which means that all the jobs near to this location. Fine. So it will just give you 100 jobs which are near to this location in an ascending order. The nearest will be on the top. It supports something called within queries. So if I want to find all the jobs within Tokyo only, you can do that. So it has a within query as well. The last is exact. So if I'm standing here, I want to find all the jobs here, which does not make much sense, but it supports that as well. So the two things that we'll be talking about is near and within. It only supports two-dimensional indexing because it only supports Earth, which is basically you just have latitude and longitude, two-dimensional things. You can have only one geospatial index per collection. That's a limitation that you have. And by default, the limits that it creates for an index is -180 to 180 because that's what Earth's coordinates are. So it can't go beyond that. Earth can only have coordinates from -180 to +180. So it's very good for building applications on Earth, and we live on Earth, so we don't need to care about. So what you need to do, you need to have one field in your document as location. Fine. And then what you need to do is you just need to create an index. when you create, you say that this is my database object, this is my jobs, is my collection, and create an index. So this is basically the syntax of creating an index. And lock is my field, and this is a 2D index that I want to create. And you are ready to go for location-aware index, location-aware apps. That's what you need to do. It's a recommended practice that you should use longitude first, then latitude. So let's get started with it. So I will just do a small demo of it to get you guys started with it. So I will just do cd/. So I'm into MongoDB. So MongoDB has some processes. So the first process is MongoD, which is basically the database server. Fine. This is how you start your database server. Install it, unpackage it, and this is the process that you need to start. And you need to give it a data directory where it should write data to. Fine. So I'm saying that start the MongoDB server on this data path. Fine. My database is started. And the second thing that MongoDB provides is a client to access it. Now that our server is running, we just need to access the client. So for that, there is a process called, or a client called Mongo. MongoD is for the database, Mongo is for the client. You just do Mongo, and you're connected to a test database. Fine. Now MongoDB, everything you do is lazily. So let's suppose I want to create a new database called testDB. So what I will do is use testDB. And MongoDB will create a database for you. It does not do anything, just it basically a virtual memory space allocation. That's what it does. So now we are into our new database called testDB. The next thing that we need to do is we need to create a collection, new collection. So there is no command like create collection, nothing. So what you do, you just say that DB is a database object, users is my collection, and I will just say insert. And I can just say username :Shekhar and password :password. So you can see this is a JSON. So what it's only JSON. It's talking about JSON. So you are saying that in my users collection, insert this document. Document is a JSON document, and you just do it. The data is written to the database. Similarly, you can have another username called Shekhar1. Another called Shekhar2 or 2. So now we have 3 documents in the database, so we can just query them. So you can just say db.users. Just do count as well, 3. Fine. And if you need to find user with just name Shekhar, so what you can do is you can just say db.users.find. And queries are also JSON documents. So you can say where username is Shekhar. So I'm saying that find all the users whose username is Shekhar. So there is only one user, so we will get that. Fine? Fine? Yeah. Similarly, you can have fields which have arrays in it. So if you're working with a relational database, what you will have another table which basically do that. In MongoDB, you can have just one document. Like I can just have db.users.find and username Shekhar123. I will not use password this time, but I will use something like tags. And I can just have an array here. So I can have A, B, C, D, E, F. Fine. So what I'm doing is now I'm creating a new document which just has username, no password, because NoSQL MongoDB is a schemaless database, so you don't have to define a schema, and every document can be different from other document. And I'm using an array called tags. And now I have persisted that, and I can just do db.users.find1 to just find a single document where user name is Shekhar123. Oops, I think I missed something. No, I want to find that. Oh, the last query is wrong. Yeah. So that should be insert. So people are not sleeping. So that was an insert. I put it wrong, and then I just need to find one. So this is my object. Fine. So you can have something like arrays, nested documents. Everything works fine. Because it does not have joins and you use embedded object, that's how it scales. So any questions before we move forward? Nope. So in our domain, this is our domain object. So we have a description of a job, we have a title for a job, we have skills like this is job for Python and MongoDB. It was created on this date. Longitude, latitude, which is basically is required for location-aware apps. So this is basically longitude and latitude. Location, I'm just using Tokyo, Japan. So what it will do is that it will basically take the mid of Tokyo and give it the coordinates. And I have a company information as well. So company is Red Hat, and this is basically my contact ID and name. Fine. So this is our document. So as you can see, this is basically the nested object. So ideally, in relational database, you have a different table, but now you just have a single document. So if I want to find out all the jobs which have MongoDB as a skill, so I will just do db.jobs.find where skills is MongoDB. So I will find all the jobs which are MongoDB specific. Fine. If I want to find out all the jobs which have skill as Python, but which should be near to this location. So what I will do, I will use skills as like the same, but I will use a near query. So longitude, latitude near to this. But before that, you have to create a location 2D index before it. Similarly, if you want to find out all the jobs which either have MongoDB or Python, you will just use skills in. So this is basically using an array, either of these and near to this location. You will get jobs for that. Any questions? So it depends upon the accuracy in terms that when you are creating an index, you can specify the bit value of like you want to have a 32-bit accuracy or 28-bit accuracy or 2-bit accuracy. The higher bits you choose, the higher accuracy you get. And by default, it's 32-bit accuracy, which is quite fine. Some meters away, but it's quite fine. Quite fine. So I can't give you the exact number, but it's in meters. It varies in meters, nothing more than that. So I can just show you, if internet works, I will show you the demo, which shows that the job which I posted from this location is just 1 meter away. So something like that. It's quite accurate. And MongoDB also can, not only it can specify the your near, it can also give you distances as well. Fine. Normally what you can do is that you can just find all the near jobs from MongoDB and use something like Google Maps to basically get the distance of all those things. But MongoDB also can support distance as well. So you write data in radians because degrees are basically radians, and you say that 1 radian is equal to 111 kilometers. So it will basically give you the data corresponding to that. I will show the data code for that. So the last thing that we need to talk about is cloud computing. After that, it's all demo. People aware of cloud computing here? Cloud computing. Anybody use Amazon EC2? Fine. Anybody has used any platform as a service? Any platform as a service? Which one? Heroku. Or any other platform as a service anybody has used? App Engine, okay. Anybody has used Openshift? Heard about it? Okay, fine. So you have heard about it, fine. So I can tell my manager there were 2 guys in Tokyo who know about it. Fine. So Openshift is also platform as a service. We will take a look at that as well. So when you talk about cloud computing, it's all about 5 essential characteristics. The first is it's available on demand. So you don't have to call anybody to use it. Just basically, if you work with Amazon EC2, what you do? You basically give it your credit card and you can get started with it. It's available over the internet. So it should be available over HTTP. It's based on top of resource pooling, which means that multiple people are using the same infrastructure. It's based on top of rapid elasticity, so you can go up and down depending upon your load. So you don't need to wait for months or days for that. It's measured, which means the amount that you use, you pay only for that. These are the 5 essential characteristics when you talk about cloud computing. There are different service delivery models. The first is software as a service, like Gmail. This is the application that you have. Is a service model. When you talk about platform as a service, it's about infrastructure as well as the application stack. Like Heroku you don't talk with infrastructure, you just talk about applications. So it basically provides you a Java stack with MySQL or MongoDB. Similarly, when you talk about OpenShift, you say that I want to create an application which should have Apache with MongoWS GUI as well as using Python 2.7 and MongoDB. So you talk in terms of applications. Infrastructure service is just a simple infrastructure like Amazon EC2. You basically talk in terms of servers or virtual machines. You say that I want to get a server which should have 2 GB RAM and 250 GB hard disk. So you talk in terms of servers. So there's a different element to all of these service models. For developers, the best part is platform as a service because we don't have to manage the infrastructure. We just have to work with the application stack. And platform manages that for you. You can have different deployment model like public, like Amazon EC2, or Openshift Online, which is also public deployment model, a private like OpenStack in your own infrastructure, or hybrid, which is basically a mixture of both of these. So our focus will be on platform as a service. So it's the thing for the developers. If you if you follow any Gartner or any other surveys or any other analytics company, you will hear a lot about platform as a service. Everybody is talking about platform as a service, and it's considered to be the future of software development. What it does, it basically provides you a pre-configured application runtime. You're not talking in terms of RHEL images or any other images. You're talking in terms of runtimes. Java runtime, Python runtime, JavaScript runtime. So you get runtimes with database stacks. So it manages the stack for you. So if there is any security update that's need to be applied, the platform will apply that for you. If there is something, a security issue coming in RHEL or anything, or infrastructure, it will apply that for you. So you are free. So you just code. OpenShift is a platform as a service. Now everybody know what OpenShift is? It's a platform as a service from Red Hat. So we have 3 flavors of OpenShift. OpenShift, like with any Red Hat product, everything is open source. So OpenShift Origin is an open source project. So it's a Ruby-based project. Anybody can fork it, start adding pull requests, and write code for it. It has 2 downstream projects. One is called Openshift Online, which is basically I will be showing, which will be running on top of Amazon EC2. So you basically sign up for an account just like you do for Gmail or Facebook. You just sign up for an account and you're ready to go. Openshift Enterprise is for enterprises who don't want to use public cloud for security reasons, for any other reason. They have their own infrastructure. They want to use that. That's where Openshift Enterprise comes in. So if you don't want to go for Openshift Online and Enterprise, you can just take Openshift Origin, install it on your own infrastructure. We provide the scripts, Vagrant scripts and Puppet scripts to do that. And you can do it. Any questions? So what we do, what we provide as our stack. So we are running on top of RHEL 6, which is basically Red Hat Enterprise Linux 6. Openshift Online runs on top of Amazon EC2. We provide Apache Tomcat for Java developer, JBoss AS7, JBoss EAP. Again for Java developer, for PHP, Python, we provide Apache. Languages type, we support Python, we support Java, we support PHP, we support Node.js, we support Ruby, and we support Perl. I don't know who uses Perl, but we support it. Framework-wise, we basically provide you a runtime. So we are not a framework company like Cloud Foundry, which basically give you a Spring stack. We provide you a runtime, so anything that compiles or run on RHEL runs on top of OpenShift. So if you have a Bottle application, a Flask application, or Django application, all of those things can work on OpenShift. We have a best-in-class Eclipse tooling. Eclipse is an IDE for Java developers, but you can also code Python in it using Python plugin. We have Jenkins integration. How many people use Jenkins here? So we support Jenkins as well. So when you create an application, you can say that enable Jenkins as well. So we will basically enable Jenkins for your application as well. For mobile, we also have plugin for App Accelerator, which is basically an IDE for writing mobile applications. We also support something called packaged applications. So if you want to, in a single click, want to have WordPress or Joomla running, just press a single click and you will get it. So this is our application stack, which is full featured. Also, it is extensible by nature. Like you can say that we don't support Redis right now in our stack. But what you can do is you can write a cartridge for it. So these all are called cartridges. We have a database cartridges like MongoDB, PostgreSQL, and MySQL. Similarly, you can write your own cartridge for Redis. Somebody has already written that, but you can extend OpenShift. So that's the main part. So this is, you're only not restricted to this, you can extend it as well. So what you need to do, just go to openshift.com and sign up for an account. It's free, you don't have to give a credit card or anything, just sign up. When you sign up for an account, you basically get 3 gears. Gears are like small servers, each having 512 MB of RAM and 1 GB of disk space. Fine. They are free for, there is no time limit on that. They are free throughout your life. It also has auto scaling. So what you can say, create is that when you're creating an application, you can say that I want that application to be auto scaling. So depending upon the load, we can basically start adding more gears to it and horizontally scale that application. Very simple pricing based upon RAM. But right now, it's only released in USA and Europe, not in Asia right now. But you can just use free account, free tier anytime, anywhere. Or if you have a credit card which has US billing address, then also you can use it. So let's get started with a demo, because that's what we wanted to do. But it all depends upon the internet. And let me see if internet is working. Yo. So let me first demo the application. So this is our application. So let me again log out and start again. So we sign in to our application using email ID. So I'm using my email ID and password is password, and I just sign in. When I sign in, I basically is referred to a job search page. I can also create a new job. So let me just start with creating a new job. I say that I need a Python MongoDB developer. Let me add 1, 2, 3 as well. The skills that are required are Python and MongoDB. Location is, let me copy the location of this place because I don't remember the spellings. Oh, what? Now I can't copy devil. Yeah, it's saying Chinese. So I will just copy this and paste it here, say Tokyo, Japan. Fine. I will add company as Red Hat. There's no opening in Red Hat like this, but I'm just using it. And I'm using just redhat.com for now. And I will just say create new job. Again, internet works fine. We should have a job created. Please work. Again, I should see if Google is working. Yeah. So we created the job, but the point is that there is something called yellow, which is basically showing the job ID. But because of, yeah. So job created with this ID. So we basically wrote it to MongoDB and come back. And now I am searching a job. Fine. So let me just do it here. So what I'm doing is I'm saying that all the Python jobs, give me that. So I do find jobs. So it is hitting a backend service, which is running on OpenShift and giving me jobs. Fine. So what I'm doing now is, so I'm rendering a Google map as well as the direction list. So I'm using Google render service, which basically gives me the directions to that place. Fine. It also tells me that it is about 1 meter and it will take 1 minute to reach there. Fine. Similarly, I have 5 such jobs. So again, because of the internet, the map is not rendering fine, but believe me, it works fine. This is basically, I'm using search with near. So I'm using MongoDB near command and Google Maps. The second functionality that we have is search with GeoNear. Here, I basically get distance from MongoDB itself. So this is the basically, I will again say Python, and I will just do find jobs. Now you can see, so it's basically very, very close. So it's basically doing minus e to minus 12. So that's what it does. So it basically gives you distance. This is all coming from MongoDB. I'm not using any external service. So all coming from MongoDB. Fine. So let's get started with application development. So we want to build some same application, but on our local machine now. So I will just stop all those things. So this is basically an empty folder. Fine. So after you have signed up for an OpenShift account, you need to install a Ruby gem called RHC, which is basically a client to access OpenShift. Fine. Once you're done that, you can start working with application development. So our first step is basically creating an application. So what I'm saying here is that RHC, Red Hat client, create an application which is named as local jobs, which is my name of the application, and it should use Python 2.7. So it will create everything for you. So I will just say this. I will just do this. So what it will do is it will basically install Apache, install WSGI, install Python on top of it, create a private Git repository for your account, pull that source to your local machine. Everything will be done for you, and you will get a Git repository where you can start making changes. Yeah, go ahead. We can run Python 3.3 as well. We can do that. So we support Python 2.6, 2.7, and 3.3. Three versions we support. So now we are creating a public DNS for your application. So it will have a proper URL, and we are cloning that to local machine. Fine. So now if I just do ls, this is the folder, local jobs. Fine. So I can just do cd local jobs, and this is the application structure that it created for me. The application is running in cloud as well. So if I just go to local jobs, shekhargulati, you will see a template application running. So what OpenShift does, it creates a template application for you. Now you have to make the changes to the source code and deploy it to OpenShift. Fine. Let's also add database to it because we need MongoDB. So what we will do is we will add a cartridge which is called MongoDB. Fine. So I just copy this command. And what I'm saying is to my local jobs application, add MongoDB 2.2 to it. So it will install MongoDB specifically only for your application. Nobody else is using it. So it's only for your application. Any questions? So it added MongoDB, and it basically gives you the root username and password for your MongoDB installation. What you can also do is, suppose you want to work from your local machine, what you can do is you can run a command called RHC port forward. So it will port forward all those ports to your local machine, and you can connect to this MongoDB server from your local machine itself. You can do all these things as well. Fine. So the next step, now that we have our application infrastructure set up, what we will do is we will pull source code from GitHub. So this is my GitHub account, and this is the application that we have. So I will pull the source code from my GitHub account. So I did that, and I will just copy this as well. This is one command, but when I copy paste it does not look like that. So what I'm saying is that I'm using Git because OpenShift uses Git for deployment. So I'm saying that add a new remote at the for this URL. This is my Git repository, and this is my public Git repository. Fine. So I'm adding that. Now I am saying that pull all the source code from this and use that. So git pull all the source code from this git remote. So I got all the source code in it. Fine. We can just open that as well. So if I just go to my location, demo, local jobs. So this is our full application. But rather than showing you the full application in one go, what I will do is I will check out different steps. Fine. So this is the whole application, but to talk about all the source code, it will make more difficult. So what I will do, I will check out different steps. Fine. So I will check out the first step, which basically is application setup, user registration, and user login. The first three steps. And this is basically my commit ID. I will just check out that. Fine. So now we are at step 1. So let's look at that. So the first thing that you need to be aware of something called setup.py. It's basically where you define your dependencies. So it basically let me view word wrap. It's much bad. So you basically define your dependencies. Like I'm defining that Flask, PyMongo, and Flask Login. Fine. I talked about that Flask is extensible in nature. So Flask does not provide anything for authentication or login purpose. So you use extension called Flask Login, which is very easy to use. You use this extension. So when we push the source code to OpenShift, these libraries will be installed. And all the source code will be under WSGI folder. That is required because OpenShift deploys the code that is sitting on the WSGI folder to Apache. The next thing is basically your app.py, which basically is your application setup. So what I'm doing here is I'm importing all the required libraries. I'm creating an instance of the Flask application. Then I'm setting some configuration things like propagate exceptions, which basically means that by default Flask will swallow your exceptions. So if you don't know, if you want them to print on your console, you just use this configuration. The second is the secret key, which is required for avoiding cross-scripting hacks. The next thing that I do is I basically define two variables, MongoDB URL and name. So what I'm doing is I'm accessing environment variables called MongoDB URL. So if the application is running on OpenShift, these environment variables will be available. Else, I will just use my local MongoDB installation. So if I'm running on my local machine, I will use my local installation. Else, I will use environment variables which OpenShift provides. Similarly, for the MongoDB name, so I'm using application name as my database name if it is on OpenShift. Otherwise, I'm just using local jobs. Now, this is part of the PyMongo, which is the MongoDB client. So I basically create a MongoDB client instance, providing it the MongoDB URL depending upon our environment. And I create a DB instance out of it. Finally, this is basically the configuration required for Flask Login, which is basically a Flask library for adding authentication information. So you can think extensions as a wrapper around the core. Core is the Flask framework. If you want to go to any other thing, you basically starting using wrappers, which are basically extensions. And the last line that we are saying is, if anybody is not authenticated, go to sign in view. This is our view if anybody is not authenticated. And we import our view and model class. Let's look at the views. Views are where we will define all the routes. Fine. So we first imported all the required libraries. Then we are saying that if someone comes to the root route, refer him to the index.html and use this as my title. If anybody goes to about, use this as my function. Similarly for the contact. Now the two functionalities that are interesting here are register and sign in. So in register, I am saying that this register URL is accessible for both the GET request and the POST request. So if a GET request comes, I just render a register page, just a form. If a POST request comes, I basically get the data from the request form and persist it to MongoDB. So here I am basically just using db.users.insert and persisting the users dictionary. And I am writing w equal to 1, which means it is in a safe mode. So it will basically write to the disk. Fine. Similarly, for the sign-in functionality, I basically, if it is a GET request, I will just forward the sign-in form. Else, I will basically get the data from the request form parameter. And using login extension, I will just log in the registered user if user exists and redirect it to the index page. Fine. A model is just a simple class called users, which basically has these properties like email, password, LinkedIn profile, URL, and skills. If you want to basically hash your password, you can do it here itself. Apart from that, these are the 4 methods that are required by Flask Login, like if the user should be authenticated, active, or anonymous. So you just put that. That's it for the first step. Now, if we basically install our libraries and run the application, it should be just working with login functionality and the user functionality. Let's move to the next step, which is basically checking out the functionality to create a job. So I will just check out this step. So now what we have is, if I just go down in my views, I added 2 more views. The first view is job/new. So if a user come to and make a GET request to it, I will just render a job.html, which is just a form. And if a user make a POST request to this URL, I will get all the data from the request and create a dictionary and write it to MongoDB. Again, very simple. Flash is basically for rendering the message on the UI if you want to do that. Any questions? No, MongoDB does not support transaction for the multiple documents, but a single document, when you insert a single document, that is transaction, that is atomic operation. But you can't have like, you can create a transaction and do multiple operations and then say the transaction commit, you can't do that. Transaction only applies to a single document. Then we will add functionality for the near command. So if we go down now, we have two more functions, one for search, another for basically an API call. So if we make a jobs/search, we will basically just render the search template. But this is basically our REST web service. So I'm using /API/jobs/skills. And these are basically my query parameters. So I will basically make a call using !lat equal to this and long equal to this. And I will just make a query just like db.jobs.find, where skills is this in this array and longitude latitude is near to this location. So the same way you work with the MongoDB Java client, JavaScript client, Mongo, the same way you can work with on the JavaScript. Then I just get that and return it as in a JSON format. The last step that we have is basically geonear, which basically means that MongoDB will also give you distance. So I will just check out that step. So now we have two more functionalities added, one for the search geoneer, another for another API call. Fine. So again, for the search form, I will just render the form, else I will get the request parameters from the request and will make a query. Geoneer command does not work on collection, it works on the database instance. So you say that I want to create a geoneer query on jobs collection, which should be near to this latitude and longitude. It should use this query where basically it should have these skills in it and limit the data set to 5 and use distance multiplier as 111. So 111 corresponds to kilometers. If you want to use miles, you should use something like 61. So, because by default, the result that it will return is in radians. So you have to convert that to kilometer or miles. And the rest, I just will render the template. And all our templates are in the templates directory. So these are all just HTML pages with some Jinja 2 templating thingies. And this is basically using Twitter Bootstrap, all the Bootstrap libraries, and JavaScript libraries. Last thing that we can do is we can just check out the master so that we can push it. So now we are at a place where we have all the code. Any questions on it? This code is on GitHub, so anybody can just fork it and play with it. And to deploy your application to OpenShift, you just do git push. When you do a git push, it will basically push all the source code to a Git repository, which is on OpenShift server. And package it and install it on Apache. So now we push the source code, and now there will be an action hook that will be invoked, and which will first stop MongoDB, which is running, stop Python, create a virtual environment where it will install all the libraries. So with OpenShift, you basically just start with RHC client to creating your application and doing all that stuff. But after that, it's all Git. Why it's taking a lot of time? Sorry? Sorry? Okay, I'm just doing completing it. So after the application is running, should be fine. The internet is also not working. So what it should be doing is it will basically installing the application to OpenShift. Fine. You can also import your data from your local machine to OpenShift. So what you can do is you can SSH into the application gear. Using secured copy, you can just move the, because MongoDB import data in the form of JSON or CSV, so you can import that data as well. And run the Mongo import command, which basically imports all the data is in the JSON format to that collection. And you can just do git push to deploy your application. There are a lot more goodies. So if you want to create an application which should use Jenkins, so you can also have -- enable Jenkins, which will create a Jenkins server, install a client Jenkins slave to your application, and you can directly use the code of that. So if you just run this command, it will create the application, install Jenkins for your application, use the source code for deployment. So your application will be ready in just one command. And if you just specify, like I have said a -s, which means it is a scalable application. So we will use HA proxy as our load balancer. So all the requests will come to HA proxy. When the number of requests goes to 16 concurrent, we spin up a new gear. So you can work with auto scaling at Jenkins as well. If you have any questions, you can ask it. Any questions? Yeah.
How well does Openshift support offline access?
Sorry?
Offline access?
Offline?
Yeah.
No. So we don't support offline access right now. So for offline access, you basically need to have your own origin cluster, that because Openshift is an open source project, so you can have your own environment for that as well.
Just one more question.
Yeah, go ahead.
And I want to know about the latency of the Openshift. So where is the hardware?
So we are running on Amazon EC2 US East Coast. We just have one data center right now. That is East Coast. So there is some latency in here. I don't have the numbers right now, but I can get you that. I don't have numbers right now. So there is some latency in it. So when we are, right now we have not released in terms of nobody can start paying us in Asia right now, because we just are having our free tier in Asia Pacific. Fine.
Thank you.
So when we go to our silver tier, which is basically a paid version, you can basically have a data center in Asia as well. Probably will have that. Yeah, you can take it. And these are my details if you want to know about that. Any other question? Nope. Thank you.